Okay, so today we're going to be talking about solving simple linear equations. The ones we're going to be looking at today are going to be single step. Now, the way we're going to be solving these is using a specific property of numbers. So, for example, if I have 2 plus 3 equals 5, something else I know about this is that 5 minus 3 would equal 2. Or 5 minus 2 would equal 3. That this additive relationship, if I need to take it backwards, I can, and I'll get all those same numbers. Now, what we have in these equations are, we have that in this first one, x minus 3 equals negative 5. So we got some number that we subtracted a negative 3, and it gave us the 5. So if we add that 3, so just doing that opposite, then we should be able to get back at what x was. So in doing this, negative 3 plus 3 becomes a 0. Negative 5 plus 3 becomes negative 2. So x equals negative 2. Okay, over here in my check, the way I check it is to rewrite in that number that we just got. So we said x is negative 2. All right, now I can evaluate that. Negative 2 minus 3 equals negative 5. Negative 5 does equal negative 5, so yep, we got the right answer. That is correct. All right, next, we've got this y plus 8 equals 0.9. Opposite of that, adding that 2.8 would be to subtract the 2.8. We're always going to do the opposite of what we see is happening to the variable. I have my variable, then we added the 2.8. I'll do the opposite. I'll minus 2.8 from both sides of this. When I do that, I then get negative 1.9 equals y. So over here, we're going to have 0.9 equals, we replace the y with a negative 1.9 plus 2.8. At that point, I can then combine both of those together. I could use a calculator to make sure I'm not making any kind of math mistakes. And then I would get 0.9. So 0.9 equals 0.9. We definitely found the right answer. All we're looking for is the value that could go into the variable that would make this statement true. So negative 1.9 is that number that gives us the right number. It gives us 0.9. Okay, now this is doing it with addition and subtraction. We're going to look at another example that's going to involve doing it with multiplication and division. Okay, so let's look at this top one. I've got a negative n over 5 equals negative 3. So we're actually dealing with two things. We've got that negative in front of the end, and we are dividing by a 5. Now, in order to undo division by 5, we just do the opposite. We're going to multiply. When I multiply, I like to put parentheses around everything on both sides, because whatever we do to one side, we are going to do to both. Now, I am going to multiply both sides of this by 5. That'll be the opposite of that division by 5. I'm also going to make this negative. I'm going to make it negative because our n right here, we have that negative right there. It is a negative n over 5. So if I multiply by a negative, I should get a positive. Now, as I do that, the number, when you've got a whole number times a fraction, it's just going to go onto the top. So I'll have a negative 5n over 5, and that'll turn into a positive 15. Now, negative and a negative, when we're talking about division and multiplication, will make a positive. 5 over 5 is just 1. So that'll leave us with n equals a positive 15. So let's come over here, test it out, change the n to 15, and we will get negative 15 divided by 5 is equal to negative 3 equals negative 3. Yes, we got the right answer. Okay, next one is a little bit different. We don't really see a number in front of the x. We do see pi, but we do need to think of pi as just a number. It's 3.14159 going on and on and on. And it's just not worth writing it down. That symbol is so much easier than writing down a long decimal. So what we are going to do is, because we're multiplying by pi, divide both sides of this by pi. After I divide both sides by pi, we will be left with x, because pi over pi is 1. Pi over pi is 1, so x equals negative 2. And there's our answer. So to check this, I'm going to have pi times negative 2 equals negative 2 pi. Well, 3 times 5 is 15. 5 times 3 is 15. The order I multiply things in doesn't really matter. So both sides of this are really the same thing. I just rearranged the order. All right, next, once again, we've got multiplication. When you've got a number just right in front of the variable, you're multiplying. So we are multiplying by 1.3. I will divide by 1.3 on both sides of this. I draw my line down through the equals so that when I say both sides, I know what those sides are, both sides of that line. 1.3 divided by 1.3 is just 1, so I have 1z. 5.2 divided by 1.3 is going to be 4. So z equals 4. Checking my answer, 1.3 times by, I'll just use parentheses for that multiplication, times by 4 equals 5.2. 1.3 times by the 4 equals 5.2. So it looks like we got the right answer. We got the number that fits in there. Now, in this problem, we're going to be doing a word problem. We want to figure out how certain things are related. So pay attention to how I kind of figure that out. In the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed. So that's what we're looking for, his average speed to the nearest hundredth of a meter per second. So I do notice I'm dealing with a few things. Average speed, that's a rate, how far he went, so I've got distance, and it told us how much time he was. Now, I've got all this information, but what's the equation and how do I figure out how these are related? One way that I approach to figuring out what equation am I going to use is to stop looking at the numbers in the problem. 200 meters in 19.32 seconds. That is just too much. The numbers are too complicated for me to work with in my head. So I'm going to use far simpler numbers so that I can figure out how distance, rate, and time could all be related. So let's say he was running at 10 meters per second. And now let's say he goes for 2 seconds. Well, I'm pretty sure that means he went 20 meters. What about if he went for 5 seconds? Okay, well that would mean 50. So each time it looks like all I'm doing would be to multiply those. So if I'm multiplying those, this was my rate, this was my time, and this was my distance. So that should be my equation. Now, I'm going to rewrite that in just a little bit of a different way, because I like to put it this way, because it's helpful to remember it's the dirt equation. So distance is equal to your rate times your time. So we know his distance was 200. We do not know the rate, so we're just leaving that as R. His time, 19.32 seconds. So if I use my distance equals rate times time, well, that'll be the equation I'm going to use, and we'll substitute it over here. So the distance was 200 times by the rate, which I don't know, and the time, which I do, 19.32 seconds. I now have an equation that I just need to solve for R. I'm multiplying R by 19.32, so let's divide by 19.32. If you do it to one side, do it to the other side as well. And that is going to equal approximately 10.35. Now, the decimal goes on past that. It goes on 10.35196687 and on and on and on. But really, when we're talking about how fast he is in meters per second, 0.0006, that kind of change in his speed really isn't significant. So those first two decimals are really all we're going to use. But because I rounded, I'm going to change my equal symbol into that approximate symbol. Okay, and I'll say he ran about 10.35 meters per second. All right, so here's our last example. On January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees Fahrenheit at 9 a.m. to negative 4 degrees Fahrenheit at 9:27 a.m. So just about 27 minutes later, it went from 54 to negative 4. How many degrees did the temperature fall? Okay, so we've got, let's just figure some of these things out. We've got our first temperature. Okay, and we're looking for how much did it fall. So we've got this temperature, and then it fell some amount. So how much it fell, and that was going to be equal to our second temperature. All right, so just plugging in our numbers, we had 54 subtract however much it fell, and that was going to equal negative 4. So in solving this, let's take away 54 from both sides. 54 minus 54 is 0, and we will have negative x equals a negative 58. Now if negative x equals negative 58, positive x should equal positive 58. So it fell about 58 degrees.